Hello everyone. Today I will talk about the difference between qualitative and quantitative seismic interpretation. The interesting thing about the interpretation is that everyone has its own opinion and interpretation of the same things, and no one understands it exactly like anyone else. That's why Frederick says there are no facts, only interpretations. First, what is the qualitative seismic interpretation? It is also known as conventional seismic interpretation technique that implies picking and tracking literally consistent seismic horizons for the purpose of mapping geological structures, stratigraphy, and reservoir architecture. The ultimate goal is to detect hydrocarbon tracks that might be structural or stratigraphic, delineate their lateral extent, and calculate their volume in the reservoir rock. Two examples for each structural and sequence stratigraphic interpretation are shown on left side. Conventional seismic interpretation is an art that requires skill and experience in the fields of geology and geophysics. Traditionally, seismic interpretation has been qualitative. Until few decades ago, it would be common for seismic interpreters to roll out their several meters long paper sections with seismic data down the hallway, go down on their knees, and use color pencils to interpret the horizons of their interest in order to map geological bodies. The geometrical expression of seismic reflectors is thoroughly mapped in space and travel time, and a very little emphasis is put on the physical understanding of seismic amplitude variations. The next is quantitative seismic interpretation, QSI. In the last few decades, seismic interpreters have put more emphasis on quantitative seismic interpretation. In contrast to the subsurface structural interpretation, QSI focuses on the physical variations of the amplitude and how it can be considered to predict the hydrocarbon accumulation. Various alterations in these techniques have contributed to better prospect evaluation and reservoir characterization. Particularly, the unconventional techniques widen the exploration area, they validate hydrocarbon anomalies and make prospect generation more easier. An example of amplitude variation with offset AVO gather and how AVO attributes cross-plotting helps to locate gas sand zones is shown on the right-hand side. The top and base of gas sand zone embedded with high impedance shale do not follow the background trend in the intercept gradient crossplot and hence can be easily identified. The most important quantitative seismic interpretation techniques are post-stack amplitude analysis, for example, bright and dim spot as direct hydrocarbon indicators, amplitude versus offset analysis, acoustic and elastic impedance inversion, forward seismic modeling. Rock physics is a science that is behind all these techniques. I will discuss each of them in detail along with modeled examples in the future videos. Few examples regarding AVO analysis, rock physics attributes cross-plotting, for example, have been shown on the left side that describe how these techniques help to extract the lithofluid information from the amplitude. These techniques, if used properly, open up new doors for the seismic interpreters. The seismic amplitude not only represent the contrast in elastic parameters of individual layers, but also contain information about lithology, porosity, geofluid type, and their saturation levels, and pore pressure as well. This information cannot be obtained from the conventional seismic interpretation. For more reading in detail, please consider the following book. You will find very interesting discussion along with field examples. All right, well, that's all I have for you today. If this video helped you, please give it a thumbs up. We hope to see you again with more helpful videos in future. Bye bye.